Hi everyone. I have recently enrolled in a IBM online course about data science and machine learning, which culminated in a final Capstone project. And in this video, I'd like to show you my attempt to resolve this Capstone project. So in first place, I would like to begin with the problem statement. And if you want to read this with more detail, you may pause the video. But in a nutshell, people in New York can call the number 311 to report complaints about their houses, and these complaints are stored in a open source database, which I will be required to get access to download that information, and then I can answer these 4 questions. So in first place, I will show you the website where I got these data frames. The first one is this website, which is NYC Open Data, and it has every complaint made since 2010, and you can see that there are 21.3 million rows that are complaints and 41 features. The link to download this data frame can be found here, API, and you can choose the format to CSV, and here you have the link. But because I was required to only download a certain number of rows and some specific features, I ended up needing to work this link, and I ended up obtaining this link where you can see that there is a limit of rows and only specific features are selected. The second database that I needed to download was this one, which has the information about every house in every borough of New York. And after I downloaded these 2 databases, I needed to upload them in the IBM cloud in order to use them later in every notebook that I create to answer every one of the 4 questions. So in this notebook, you can see that I attempt to solve the first question, which states which type of complaint should the Department of Housing Preservation and Development of New York City focus on first? This question is very simple and straightforward, and basically I need to find where is the top complaint. Here I started by importing the specific packages and also the data frame that I have downloaded and is in the cloud. Here you can see the data frame with every feature. You can see that we have the date when it was created, the complaint type, and so on. Here I show the type of every feature, and you can see that the majority are objects, then floats, and then one integer here. You can notice that the date feature is an object, but I like it to be in the date format, so I change it, and you can see here that now is in the date time format. I was required to only work with information that was collected until the 31 of December of 2018. So I started by adding 2 more columns to my data frame, one representing the year and the other the month. And you can see that they are right here. Then I only added this line of code here to filter the information that I wanted. It is important to note also that after 2014, the Department of House Preservation replaced the name of the heat hotter complaint to heating. So I decided to merge these 2 complaints to make everything more simple. So you can see here also that the top complaint is definitely the hitting complaint, with almost 200,000 complaints. I decided also to make a bar chart, and you can see again that the hitting complaint is by far the top complaint. I decided to go even further, and here you can see a graph where you have the year in the x-axis and the number of complaints in the y-axis. And again, you can see that the hitting complaint is a top one, and you can also see that there is a tendency to increase the number of this complaint year after year. Then I made a second graph where I have grouped the created year and the complaint type, and you can see that year after year the top complaint is again related with hitting issues. Finally, I had saved this data frame so I could use it in the following questions in order to save time. Okay, in this notebook I have my answer to the second question, which states, should the Department of Housing, Preservation and Development of New York City focus on any particular set of boroughs, zip codes, or streets for the specific type of complaints you identified in response to question 1? Basically, focusing first on the complaint that I identified in the previous question, which was hitting complaints, I should find the boroughs, zip codes, and streets where this type of complaint happens to be reported with more frequency. So I started by importing the specific packages and the data frame. And here, in order to make the data frame lighter, I only focus on this set of features. And then, because we already know that the top complaint is related with hitting issues, I started by filtering the data frame to only contain this type of complaint. Then I've made this data frame that it will be only useful when I will make a map to visualize the information, and it will be at the end of this notebook, so for now it's not useful. Here you can see already the borough of Bronx and Brooklyn have the higher number of complaints. And here I have the code that I've made to visualize the data in an actual map. And first, in order to obtain this map, I needed to go to this website that it's the same, NYC Open Data, and they have this open source map that everyone can use and integrate in their code. And I basically needed to go to the Soda API and obtain this link that then I've used here, and the rest is some programming stuff in order to make this graph here. And you can see that the borough of Bronx and Brooklyn have the higher number of complaints, and every dot that you see is the exact location of the complaint. So after this map, we can see already the boroughs with the top where the complaints are most reported. So we should make the same process to find the exact street where this specific complaint is more reported, and the same thing for the zip code. Finally, here I have printed the borough with more complaints, the street, and the zip code. Again, I saved this data frame to use it later in the next question. So here we have the third question, which states, does the complaint type that you identified in response to question 1 have an obvious relationship with any particular characteristic of the houses or buildings? And this third question is a little bit more complex than the previous two, because I will need to merge two different data frames. The one that I've worked in the previous notebooks, and the one that contains information about every house in New York. And here we have the code to import the packages and the two different data frames. And here you can see that I have isolated the borough of Bronx and also the complaint type of heating. Then here I show the data frame that contains every information about every house in New York. Before proceeding in this notebook, I should refer that I took two different approaches to solve this third question, where the first I focus, I will create a column which has a binary state, which is 0 or 1, and is 0 when there are no complaints, and 1 when there is a complaint. So the first approach, I started by creating that column, and as you can see in this first data set, it is always 1 because this is the data frame that corresponds to every report that was made, and it makes sense. Then I merged the two data frames, and when there are no coincident zip codes and street names, I decided to fill with 0 the values in this column. So it will be 1 when the two data frames are coincident, and that means that there is a complaint regarding those features, and it will be 0 when having all those features there is not a coincident address with a complaint data frame. Moving on, here I have generated the Pearson correlation and the p-value of each feature of this merged data frame, comparing with a heat complaint chart, which is this column here, the binary state. And here we can see that the features which have the highest Pearson correlation are the year when the building was built, with almost 80%, and then the number of floors and some other features. And this one makes sense because obviously if you have a very old building, the number of complaints will probably be higher. We can see also here the p-value, which is important to note that it's almost 0 in every feature, and this is probably because we are only taking into account the heat complaint churn, which has a binary state 0 or 1. Okay, so for the second approach to this method, I decided to add a column that instead of being a binary state, I have grouped every street and the IP code, and here we can have the number of complaints for the street and the zip code. And having this, I have made the same steps where I merged the two different data frames, and then I have generated a Pearson correlation and p-value of each feature, but this time regarding the number of complaints. And we can see again that the year when the building was built has the highest Pearson correlation, but it's important to note that it's not as high as in the first approach that I've made. Another thing that is important to note is that the p-value is not always close to 0 as it happened in the first approach. So at the end, it is important to note that there are in fact some characteristics of the buildings that may be directly correlated with the number of hitting reports in this case. Finally, I will show you my answer to the fourth question, which states, can a predictive model be built for a future prediction of the possibility of complaints of the type that you have identified in response to question 1? And basically having the data frames of the previous notebook, I will have again two different approaches. The first one where I have a column with a binary state, and the second one with the number of complaints for a given set of building characteristics. So in the first approach, I have used a logistic regression method, and I will not go into details about the code. So I will jump into the major conclusions. And here you can see that the Jacquard similarity is almost 100%, which is very good. And I have also calculated the confusion matrix, and as you can see here, every time the true label is equal to 1, the predicted label was also 1, the majority of times, of course. There are only 635 times that the model didn't predict well. And the same applies to the churn 0, where the results are also very, very good. So when the churn was 0, the majority of times the model predicted a churn equal to 0 as well. So finally, still for this first method, I have calculated the log loss, which is almost 0, which is also a decent value. For the second approach, I have used the key nearest neighbor method, which is a classifier. Again, I will not go into details about the code, but basically I needed to identify two different sets, one for the training part and another for the test. So here you can see that the train test accuracy is 97% and the test set accuracy is 96, which is great. Here I have a graph where I I progressively increased the number of neighbors and plotted their accuracy. And as you can see, the accuracy is higher when the number of neighbors is equal to 9. So basically, this model is good for the second approach, where we could have a set of random house characteristics, and this model would give me the number of complaints that it would most certainly happen given those specific features. So that's it for this fourth question. I have built two different models, one for this first approach and another for the specific second approach. And that's it. I have answered all the 4 questions. So thank you very much for your attention.